Okay, hello everybody. Hello, hello, hello. Shh. I've got to hit the button. So, let's talk about assignment 0. Okay, so as you might remember from Wednesday last week, I talked about the assignment is going to involve converting a time that we give you into a time in your local city, where your local city, we also tell you what that should be. The website's just getting refreshed with the assignment spec on it, so until I can show you that up here, I wanted to talk a bit about time zones. So, why do we have time zones for a start? Like, a time zone means that it's a different, like it's currently, 1:24 p.m. for us. But simultaneously, at this very point in time, it's not going to be 1:24 p.m. in New Zealand or in Europe. Why do we have time zones? Cool. Did people who are not sitting within a row of Adam? Was it Adam? So did people up the back hear that? Yes, sort of. So I'll record it for the web stream. I'll say it again for the web stream people. So the reason we have time zones is because the Earth is round, it's a sphere, and so that means the sun is going to be like shining on Australia at a different time to when the sun is shining on Europe or China or the other side of the world. And so it makes sense for us to call the time that's called noon to be the same level of daylight or the same sun position as it is in different places. And so Australia is, oh, there's a picture, cool. New Zealand's the best part of Australia, clearly. So Australia, because it's so large, the time at which, like if we're in Sydney and it's currently noon, so it's 12 o'clock p.m. and the sun is in the very middle of the sky. In Perth, we could say that it's noon there as well, like we could declare that time as noon, but it's effectively in 2 hours' time, the sun will be kind of in the middle of the sky. And so it'd be confusing for the people who lived in Perth if noon in Perth meant the sun's still kind of getting there, and noon in Sydney meant, we're about to hit the afternoon and the sun's going to start setting soonish. And so we have different time zones with different offsets to sort of try and approximate when the sun is in the middle of the sky, we're going to call that time noon. People up the back, can you see the font size with that? Cool. So this is just a diagram showing various parts of Australia in their time zones. So we can see in Perth over here, or in the green, I'm not Australian, I'm going to get this wrong, is that called Western Australia? Cool, Western Australia. I'm sorry, people from Western Australia. So over in this whole chunk, the time zone is what we'd call UTC plus 8, which means it's 8 hours shifted from the benchmark we call UTC. And that one is called Australian Western Standard Time. In this section here, they're in UTC plus 8:45. So if it's currently like noon in Perth, it's going to be 12:45 p.m. in Darwin and Alice Springs. Not confusing at all. And then, hang on, no, that's 9:30, so it'll be 1:30 p.m. Down here in Usula, it'll be 8:45 a.m. It's offset by UCLA. Okay. Apologies. My ability to pronounce things comes from learning Latin, not from knowing real languages. So yeah, in this section here, it's going to be this time zone. We can see in New South Wales, Sydney, and Canberra. Have this weird thing called daylight savings, which is, you know how in the wintertime the days are shorter, and so, because the length of the day is like the amount of sunlight we have, and we have less duration of sunlight in the winter compared to in the summer. And some clever person thought, it's really annoying waking up and it being cold and dark, so let's have daylight savings. Let's change the definition of what the time is over the winter so that we can have the sun rise an hour earlier than it sort of technically is. And there's much dissension about whether Australia should observe that, but in some parts they do. And so that means that during the summer months, the time zone becomes 1 hour more forward. Tutors, is the website up yet? Okay. So the time zones have names, Australian Western Standard Time, Australian Central Western Standard Time, and so on. You'll be given all of these in the assignment. And you'll be giving something, for example, the current time in UTC is 3 p.m. What's the current time in Sydney? So how will we go about calculating that? If we know that the current UTC time is 3 p.m., and we know that Sydney is in UTC plus 10, what would the time in Sydney be? It would be 1 a.m. Cool. So if we have 3 p.m. and we add on 10 hours, that's 4 p.m., 5, 6, 7, 8, 9, 10, 11, 12, so we've hit midnight, and then 1 a.m. makes 10 hours we've added on. Cool. How did you do that conversion? Yeah, so yeah, 3 o'clock in the afternoon plus 10 hours. If we use 24-hour time, how many of you have heard of, how many of you have not heard of 24-hour time? If I say 24-hour time, you're a bit confused. Some of you are a bit unsure. So I'll open a notepad document. When we say something like 3:30 p.m., when we say something like 3:30 a.m., in 24-hour time, that's just 3:30. We can put a 0 in front to make it clear that it's 24-hour time. But then if we have 3:30 p.m., 3:30 p.m. is 12 hours after 3:30 a.m., so we just add 12 onto this number. Which gives us 15:30. So when we're writing like AM and PM 12-hour time, we've got to wrap around, so we go, 11 a.m., 11:59 a.m., 12 p.m. is noon, 1 p.m., 2, 3 a.m., 11 p.m., 12 a.m. becomes midnight again. But to make it less clear, to make it more specific which time we're talking about, and to avoid having to say AM or PM, we can use 24-hour time. So 15:30 means subtract 12 hours, gives us 3:30, so it's 3:30 in the afternoon. And so we could do that math. What did I say before, 3 a.m. or 10 p.m. or something? Yep, so if I have 3 p.m. In UTC time, we can write that as 1500. And so then if I want to convert from UTC time, so if Sydney is in UTC plus 10, I can take my current time, which is 1500, I can add on 10, or kind of 10 hours, but then to make it into the 24-hour time, that's sort of like 10 hours. And that would give me 2500, but that's not a valid time because times, instead of hitting 24, we go back round to 0, 0. Yeah, you could use mod for that. So you could go, so we could use mod. We could say, we've got the hour 2500, but that doesn't make sense because hours, days finish at 2400. So divide it by that and take the remainder, which is 100. And so that gives us that it's 1 a.m. Effectively, it's 0, 100, we're saying 24 hours or 1 a.m. Cool. So there are upsides and downsides to having everything being on GitHub and everything being kind of centrally controlled, and tutors can just push something and it goes to the website. But the downside is that it means it takes a while to get working out. So assignment number 0, what time is it for you? And this website looks different to the normal one. This is like, when you have the lab pages, this is where they're stored and then they get linked inside WebCMS. So this will also become inside WebCMS. So the assignment is about, what time is it for you? It's an individual assignment. It's due at the end of week 5, so Sunday the 26th of August. So you have 2 weeks to work on it. So you should have a read through this yourselves, but I'll go over it sort of in a high level. So your task for the first assignment, assignment 0, is to write a program that will work out what the local time is in your city to help me get the time zone conversion correct so that you don't get waken up at 3 a.m. with a phone call. And so you might remember from Wednesday's lecture, I talked about how I'm going to call the student who had the most fantastic final assignment, and I'm going to go, your assignment was fantastic. And I will do this, and I will use your code for this. So you want to make sure that your code is correct, because otherwise I might accidentally wake you up at 3 in the morning. So that's just what I was saying in Wednesday's lecture, but we'll give you a city in Australia and New Zealand. We'll give you the day and the month. It'll be in 2017. We'll give you the time in UTC. And your job is to convert that to the local time in that city. And you don't have to worry about scanning in the time yourself. We'll give you a function which has those as inputs, and you've just got to fill in the function. And so your job is to take the stub code below, which may or may not be below at the moment, but it's uploaded, and finish implementing the local time function it contains. The main function provider runs a series of unit tests on your function to see if it contains an error. And you might be saying, what are unit tests? That's weird. It's not a thing I've heard of before. But unit tests are a series of small tests to test kind of self-contained parts of your programs or units of your programs. So as an example, we were thinking before about how we could tell if our program was correctly replacing the multiples of 3 and 5 with zeros. And so we tested the case of if it's a 3, if it's a 5, if it's a 15. But then we also had to test cases like, is it a 4? Because a 4 is not going to be divisible by those. So we want to make sure that it's working for those cases as well. And so when we write tests for our programs or tests for our functions, we need to kind of consider all of the possible cases. And so rather than just going, I'm going to test that it works in Sydney time, you've got to think, well, you know, what about Sydney time that's in daylight savings? And what about if it's in Perth time, but it wraps across to the next day, like we had before with that, and so on. So we give you a set of about 20 tests to start out with, and you should write some of your own to make sure that you're covering more cases. There are a lot more than 20 possible kind of cases that we can have. So we've given you some to start with, but you need to make sure you add more. And one of the parts of the assignment is going to be to add at least one test yourself to the list of assignment unit tests. And I'll put the link up there when I work out how on the course website I can actually have that set up. But we'll sort out some way to do it, and you'll have to contribute at least one test of your own to that list of tests. And you can collaborate and share tests amongst each other with your lab partner, with your friends. It's fine to share tests, but it's not fine to share solutions for code. So you can't share your actual program, your function, how that works. So this is kind of a tangent about plagiarism. It's always fine to discuss ideas. It's fine to talk to your friends and talk to your lab partner and go, hey, I don't understand what a time zone is, or how do I convert a time zone, or you add the number on, that sort of thing. But never share code, never show someone your code, never write down code and give it to someone, that sort of thing. So discussing ideas and concepts, totally, highly recommended. Sharing tests, which technically are code, but test code, completely fine. But sharing your actual assignment code or kind of writing down your assignment code on paper and giving that to someone or that kind of thing, not okay. So you can read through why this assignment, because it's a very good assignment, some tips for getting started. It's really important with programming in general to understand the problem well before you start trying to solve it. I'm sure those of you who are experienced programmers know that if you rush into something and you go, I'm going to solve this thing, I know what I'm doing, it's going to be great, and you just start coding madly, you then go, hang on, this doesn't work, or I haven't considered this case, so what if it's this? And you've got to kind of try and change your code and add stuff in and kind of mangle it around to achieve what it should be achieving. Whereas if someone else started out from scratch and thought about it before they wrote their program and kind of went, I'm going to design my solution, I'm going to do this and this and this, and then started coding, they'll have spent more time at the start. They'll have started coding later on because they spent time designing their solution, but they won't spend nearly as much time trying to debug and trying to find mistakes they've written. So be the person who draws the diagram. So make sure you understand it well. Do examples with pen and paper, draw some diagrams. And only once you know exactly what you're going to do, only once you've sort of designed your solution, then you should start coding. So to actually do this, copy the program stub before, the skeleton code, like sort of the base code, which I'll show you in a second. Make sure you understand time zone conversion, and we'll put some resources on the website. Contribute at least one good test to the shared unit tests. And you might be thinking, why would we do that before we start coding? But if you think about it, it's good to write your tests before you write your code, because then when you write your code, you can test if your code's correct. If you write tests after you've written your code, you might write tests like to your code. So you might go, oh, my code has this if statement here, so I'm going to test that this if statement does the correct thing. But the risk there is that if your code is wrong and you're testing that if statement does what you want, you might be testing the wrong, have an invalid test something that's incorrect. So by thinking about the test cases before you start and writing some tests before you start, you won't be biased by how you've written your code. So once you've done that, edit your copy of it below, add some code to make it work. Once you're confident that your code is correct, by running it yourself against the unit tests that you've written and that everybody else has written that you're sharing, then you can submit it below and leave all the tests in your code. So restrictions, must follow the style guide. Don't use any syntax we haven't covered yet, so you can use functions. You can use everything we've seen up until the start of this week. So functions, variables, if statements, all that kind of thing. But nothing that we're going to learn from this week onwards. Yeah, and don't change the hash includes, don't change the function. You can write more functions, but don't change the type signature of the function we've given you, don't change sort of the prototype, and don't hash include any more things. Cool, so write your code in a file called localtime.c and submit it below, which is going to be below on the course website. Okay, we've got the skeleton code for you here, which you can view over here, and you can copy it to CSE by copying this command, which I would do in VLab. That's, oh, did sort of copy. No, that didn't copy. So incidentally, how many of you have managed to get copying and pasting in VLab working? Has anyone managed to do it? A couple of people. That's really fantastic. How did you do it? Is there a way I can do it in here? Maybe under options. Input. Accept, send clipboard. Okay, apparently it should be doing it already. Okay, it does work. Just go to copy and paste like that. Cool, so you might want to make yourself a folder called assignment 0 or something. Go in there, run this command that we give you, and then you've now got your own copy of the thing called local time. And you can see over here, whoops, program to test this function, program sub created by me, this program by your name here, your ZID on insert date here. So we've given you various cities. So we will be giving you like one of these cities. We won't give you any cities outside of these. So we've got some capital and noteworthy cities in Australia. We've given you the time zones. So the offset for time zone Australian Western Standard Time is +8. We've given you a series of tests. So what? Yep. We've given you a series of tests. So these are some cases already that we've made for you. You'll want to add your own tests here and then fill in this function here yourself. So this is all on the course website. You can look at it all there. You can ask your tutors or me any questions. You can post questions on the course website. Cool, but for now, let's go on. Cool, so think back to week 1 or 2. And we have if statements, right? Hopefully you're feeling pretty confident about if statements. We have, for example, in our program we can get a number, and if our number is less than 10, if a condition is true, then do something. In this case, print hello. And sometimes else do something else. But in this case, we've kind of got if the number is less than 10, then print out hello. But what if we wanted to do this more than once? So maybe instead of wanting to print hello once, we want to print hello several times. And so you can see we had in here, if num is less than 0, then do something. So if the thing in the circle brackets, open curly brackets, the thing to do. And we can change to do it more than once. Instead of an if, we can turn it into a while. So rather than saying if num is less than 0, then do this, we can say while num is less than 0, do this. So basically, for as long as num is less than 10, you know, if num is less than 10, then keep doing this over and over again. And then if num becomes not less than 10, then stop and move on. So let's have a look at this real quick. Lab. So I've got my beautiful code here. I'll change it to an if statement for a start. I forgot all the other parts of my program. Cool. So I can compile and run my program. And so for the moment, it's an if statement. If the number I give it is less than 10, then print out hello. But I can turn this into a while loop, which instead of saying if it's less than 10, do this, say while it's less than 10. So, you know, as long as it's still less than 10, keep on doing this. And so let's do that. Try number 7. Hello. So I've run into here what is rather infamous in programming, what we refer to as an infinite loop. I've given it 7. Num is 7. Num is always going to be 7. I'm not changing num at any point. And so it's just going to run forever, printing out hello, because num is always going to be 7. So it's kind of silly, right? This is just going to print hello forever. That's a bit silly. But we can change it to do something like this. We can add in, somewhere in our while loop, we change the condition that we're looking at. We change the things in the condition. So we can't change it to not be while num is less than 10. It's always going to check that. But we can change num. We can change what num is going to be. And so we can add in this line num++ into our program. You might be thinking, what does that mean? So we can say something like num equals num plus 1. So we can say take this variable and make it be itself plus 1 more. We can turn that into shorthand. We can say num plus equals 1, which means num equals num plus itself. Sorry, num plus itself, no. Num equals itself plus 1. But because adding 1 to something is so common, there's another shorthand, just num++, means add 1 onto num. And so now if we run this, what do you think will happen if I put the number 7 in? It'll print out hello, and then num will become 8, and then it'll print out hello, and num will become 9, and then it'll print out hello, and num will become 10. And then 10 is not less than 10. So we were only doing it while num was less than 10, but now num's not less than 10, so we'll stop. So let's see if that works. Cool, so we've entered number 7, printed out hello, hello, hello. And so loops, just like anything else in programming, are made up of several components. First of all, we have our initialization. And this doesn't necessarily have to be part of the loop, but we do need some variable that we can use in our loop to control what's going on. So in this case, we're initializing, we're saying, give me a variable called I, and make it start at 0. Then we have our condition in our while loop. So like I would say if this thing is true, instead we say while this thing is true, while our condition is true. Then we have the statements, the actual code that happens inside our loop, which in this case is printf hello and then number %d, whatever number it is. And then we have our update, where we actually change something to make our loop continue going and eventually stop. So in this case, we're updating by saying I equals I plus 1, or we could say I plus plus, as an example there. Cool, and yeah, here's just a quick slide covering that. So we can say I equals I plus 1, we can say I plus equals 1, or we can say I plus plus. Those are all going to be the same thing. And similarly, the same thing for minus. So we could do like I plus equals 5 here to add 5 to I. We can do I plus plus just adds 1 to I. Okay, ready to look at the number 3. So what if we took our 3's function, and what if instead of printing out, what if instead of just taking 3 and turning it into either 3 or a 0, sorry, if it's a multiple of 3, turning it into a 0, just for the one number we scan. And what if we go through a whole series of numbers? I might keep them like this because I like this way better, no offense to Adam's suggestion to do it this way. But if you remember from before, we have our function remove 3s that will remove the 3 from our code. We have the function remove 5s, which will, again, if it's a multiple of 5, change it to a 0. Okay, and so rather than scanning in some input, let me try that again. Rather than scanning in some input and just doing that one number, what if we do all of the numbers, say, from 1 up to that number? So if I typed in 5, then it should do the numbers 1, 2, 3, 4, and 5. So I'll save that for later. Let's it's turning into a little bit of a too long function name, print without 3 or 5, but let's make a function here. It's going to take in the number we want to look at, so we'll give it the number inside our function. We'll get it to change the number that it's given. So take the number that we've given you and then remove the 3s from it and remove the 5s from it, and then print it out. I'll print it on a new line. So this should do just what we had before in here. It'll take our number. If it's a 3, it'll print out 0. If it's a 5, it'll print out 0. If it's a 9 or a 15, it'll print out 0. But if it's a 4, it's not a multiple of 3 or 5. It'll just print out the number as it is. So print without 3 or 5. I'll call it down there. I'll get rid of that print because I'm printing it out inside there now. Cool. So we can see we've got our input from before. Please enter a number, scan the number. It'll print just that one number again, and then return at the end. Threes. So if I enter a 4, I get a 4 still. If I enter a 5, I get a 0 because it's multiple of 5. 15, multiple of 3 and 5. So this is just our program from before, but in a function. But now let's turn this into a loop. So while something, we want to print it without a 3 or 5. And so remember, whenever we have an open curly bracket, everything inside gets indented across 1, which is why I put in 4 spaces, hit tab here. So what should our something be? While what? I said we wanted to print out everything from, let's say, 1 up until the input, right? So while the one we're up to is less than the input value we were given. But we can't just sort of say the one we're up to. We've got to actually declare this variable. And I'll initialize it to have the value 1. So look at the value 1. While that's less than, so we're starting with 1. While the one we're up to is less than the input we were given, print out that number with input. Now, if I run this, so if I give it, say, the number 5, I'm going to expect that it'll print out 1, 2, 0, 4, 0. Because it'll turn the 3 into a 0. Something's gone wrong. So what have I forgotten to do in my loop here? You can see it's given me just straight 0 and nothing else. Change the value of up to. Cool. So if we do this, up to plus plus, run it again. So now if we enter the number 5, it's still just printing out zeros though, which is not really what I wanted. But I've made a mistake here. I've forgotten to change this to what we want it to be. So if you remember, we want to print the number that we're up to, whether that's the 1, 2, 3, 4, 5, turning them into zeros. So I've got to change this to give it, hey, take in the number that we're up to, and print that one out. So let's run that again. So now if I give it a 5, it's going to print out 1, 2, 0 instead of a 3, 4. It hasn't printed out the 5. So why is